Good and welcome. My name is Nyakalo Lepoto. I am a tutor here at Tusabana Community Center. We specialize in English, Sesotho, and mathematics. There on your screen, you will see my contact details. So to get to them and highlight the important parts where you will be able to get in touch with me. My full name there, Nyakalo Lepoto. My cell phone number 078-383-3396. Email address nyakalo.lepoto@gmail.com. We have online classes for learners from grade 1 up until grade 12. Mondays to Fridays, 6 p.m. to 8 p.m. The class doesn't necessarily take 2 hours long. What happens is we have 45-minute classes in intervals, right? Then 40 minutes rather, Zoom. So you will get the story. We also have classes for B.Ed students. Be aware that these are morning classes, 10:30 a.m. to midday. I feel like I need to highlight that because I didn't write a.m. People might think it's 10:30 p.m. in the evenings. That does not work for us. What works for us during the day. So you'll just check the days where you don't have class, then we can have that. If you are studying online, maybe we can try and squeeze you in during the later classes. Say you're studying B.Ed via online, or you're also working, and we will have to move you there. We are going to do mathematics. Today we will be doing, I want us to do algebraic expressions. It's not a very difficult part of mathematics, but it has to be done. Nonetheless, feel like it's free marks. If you master these, you will be fine. What we need to do is to explain the different expressions that we find in mathematics with regard to algebraic expressions. The first one is what a constant is. My cursor keeps disappearing, so sometimes I wouldn't know. So basically, a constant is a value or a number that never changes in an expression. It's constant. It remains the same. Basically, how you would spot it in an algebraic expression, it would be, let's go back to our algebraic expression here. It would be a value that does not have an unknown on it or next to it. So a number that does not have an X or an A or a Y. We will get to what a variable is. But basically, in this expression, 5 would be our constant. It doesn't change. It remains the same. It is not accompanied by an unknown like A or whatever. Like in this case, 2A walks along A, works together with A, accompanies an A. But this one is stand alone, so it's a constant. Regardless of what the value of A would be, this 5 will always remain a 5. That's why we refer to it as a constant. Let's move on again to our expression. In this case, the definition of a variable or variable, depending on which school you went to, it's a letter representing some unknown. Let's go back to our PDF here and see what an unknown variable there is. So that would be an A in this case. But commonly we have an X or a Y that is a variable. It changes from time to time, as the expression says. It's some unknown. It changes from time to time. The coefficient is a friend of a variable. It's a number that is being multiplied by a variable. So for instance, if we say 2x or 2y, the 2 there is a variable. The one of the common mistakes that I see our learners making is to when we ask them what a variable, for instance, what a coefficient of a squared is, they will say it's 4a squared. But it has to be just this number that is accompanied, that is working side by side, a squared. Right? My name is Nyakalo. If you say, who is this guy standing next to Nyakalo? You wouldn't say it's Nyakalo and Tabo. His name is Tabo, but he is working alongside me. Now, the variable has to be accompanied by the sign. So it's, in this case, it would be -4 instead of just 4. That's another common mistake that our learners make. Let's move on to the next definition here. After the coefficient, we will have the degree of a polynomial. The degree of a polynomial basically is the highest power or the highest exponent. We'll get to what an exponent is. Let's move on to the PDF again. Let me just do the side by side, just for interest's sake. In this case, our highest power, you see this thing, the small number next to the variable here is called an exponent or a power. It's basically how many times a number is being multiplied by itself. So if it's a squared like this, it means you are multiplying a by itself. A to the power of 3. If you hear a sound in the background, the children have just arrived, our day scholars. So yeah, it's just one of those things. We are an aftercare center. I didn't time my recording well, but it has to be done. So the highest one here, the highest exponent is 4. So in other words, the answer for 5.1.2, where they're asking us what is the degree of the above expression, it would be, you will just write 4, because that's the highest exponent. Let us move on back to the definition. Sometimes they would ask you to sometimes they will ask you to arrange the expression in descending order. So descending order will basically be from highest to lowest exponent. So basically that would be that. As you can see, our expression in this case is not arranged in order. I just want to go to our expression again so you can see. Let's just go to side by side here. What our exponent is, what the expression, right? -4a squared, 3a. So we'll have to move this to, say, we will start with the highest exponent, the one thereafter, then thereafter, and then we will end with a constant. I'm just going to try and write it. I use a mouse to chart my stuff here, so it won't be the steadiest of handwritings, but it does the job. Nonetheless, it does the job. So we have this expression as, I'm just going to go back to the expression. You're just seeing a blank space there. It's just not a good look. And put my face there at least. So you can see that you haven't lost me. Our expression is -4a squared minus 3a. Let's move on to that. -4a squared minus 3a. They'd say the handwriting won't be the steadiest, but it will do the job. I'll get one of those stuff when the center grows. We will have that minus 4a squared minus 3a. So this is an opportunity for you to help us grow. Subscribe or enroll so we could afford these fancy tools that we need for our job. So that will be 5 plus 5a plus a cubed plus 5a plus a cubed. It's moving around. This program is a little cumbersome, to say the least. Plus 5a, so that will be plus just 5 plus a to the power of 3 minus 2 to the minus 2a to the power of 4. Why are we doing this? We're trying to rearrange this in descending order. So I did say that a to the power of 4 is the highest one, so we'll take that. So we'll say 2a to the power of 4. So we are doing it from highest exponent to the lowest. The next one would be from 4. Immediately we'll move to 3. Okay, believe it or not, this is a to the power of 3, then minus 4a to the power of 2, and then minus 3a right up to plus 5. Now that would be descending order. It would be from the largest exponent to the one immediately thereafter. 4, 3, 2, 1. We know that when we don't have anything here, it's a 1. And then the constant one, the one that is stand alone. So basically that's what it would mean to arrange in descending order. I need to move to, so the exponent, I think I have covered the exponent. The exponent is a power. It's what is also known as a power, but it's the number of time that either a number or a variable has been multiplied by itself. So 3 multiplied by 3 is called 3 to the power of 2, or 3 squared, which is 9. A multiplied by a is a squared. We will get to that. It's not necessarily important for the lesson today. I want us to move on to the next question. Now that I have given us the expressions and the definitions, let's look at a real life explanation. This one we have done basically. The constant here would be a 5. A degree, we did say it would be 4. Write down the coefficient of a to the power 4. Coefficient of a to the power 4 would be minus 4. Remember, I did say that it goes along together with the sign. Then we will arrange the expression in descending powers of a. We have done that, from 4 to 3 to 2 to 1, right up to the constant. The constant is always last. The highest degree is always mentioned first. Let's move on to a real life question here again. Just need to go to the PDF so you can see the next question that we have. It moves something like this. I'm going to chart this on our paint, and then it won't be the prettiest of handwritings, but it will do the work. So basically, the first question here, there's our expression. Here's our expression. 7y to the power of 2 plus x. No, it's not y. It's x. It's y. Y to the power of 5 over 3 minus 6y plus 2. It's also not written in descending order. So one of the first things that they might ask us is to do that, but they're not. So the number of expressions is something I did not mention. The number of expressions is, the expressions are divided by the negative or the positive sign. So anything that you see on either side of plus or a minus sign is an expression. So this whole number is the first expression. This one is the second expression. This is the third expression. And the last one is this. So this one would be 1, 2, 3, 4 expressions in this particular case. So that would be the answer for that one. Then the coefficient of y or to the power of 5. Let's check this one on our paint so that at least we have a better picture in terms of how we're going to look at the exponent. I want to keep scrolling back to our PDF. So that will be 7y squared. The original expression is 7y squared plus y over 5 over 3 plus, no, my goodness, it's not y over 5, it's y to the power of 5 over 3 minus 6y plus 2 minus 6y. I'm using a mouse here. It's very cumbersome, but it does the job. 7y squared plus y over 5. So now they are asking us for a coefficient of this number, right? So in this case, when you see a variable like that, a coefficient of y to the power of 2 would be 7. It would be very simple. In that case, the coefficient of y would be minus 6. Very simple. But when it's a fraction like this, y over y to the power of 5 is also equals to 1 over 5 y to the power of 3. Therefore, the coefficient of, sorry, it's y to the power of, it's y to the power of 5 over 3 is equal to 1 over 3 multiplied by y to the power of 5. So the coefficient in this case would be 1 over 3. So that would be the answer to our, the second. Kids are increasing in number there, so there's a bit of commotion in there, but we will still be working. It gives you the feel of a classroom. I feel like I won't be editing this out. I won't be editing this out. So we are here now. Write down the constant term. The constant term basically is just 2. That's the number that doesn't change. The number that's moving alone, the walk alone, the stand alone, plus 2. That one is pretty simple. Then rearrange the expression in descending powers of y. So now we are going to have to move back to our page and chart the answer for this one. It's not in descending order, as you can see. The highest power is this one, to the power of 5. So that's the first one we need to start with. We are going to say y to the power of 5 over 3. The second one would be 2 here. So that's the one we are going to move. We'll say plus 7y squared. Then another y we have is minus 6y. And then we will end off with our constant. Basically, that's how you rearrange that in descending order of the powers of y. Right, now we are going to move on to the last question in this case, which is the last question in this case is if y is minus 1, calculate the value of the expression. Right. So wherever we see y, we are going to substitute that with minus y. Let's move back to our paint. So I want us to do the paint integrated might just work for us as well. No, side by side works better. Let's move back to our paint. Just need to change this and say where we are seeing why we are going to change that to minus 1. So it's 7. We'll put a bracket here. We'll say minus 1 squared. We will then have plus minus 1 to the power of 5, bracket, over 3. We'll have minus 6 multiplied by minus 1. The constant is standalone, it doesn't change. Now you understand why it's called a constant. There we are. So we are going to start bottomers. We're going to start with our brackets. So the 7 here, we'll leave it as it is. So that will be 7 multiplied by 1 squared is 1 multiplied by 1. Negative 1 multiplied by negative 1. Negative multiplied by negative gives us positive. 1 multiplied by 1 gives us 1. So then we are going to have negative 1 to the power of 5. It's going to be negative 1 divided by 3. Perhaps I should just go negative 1 over 3. Not the best actually to do, because it won't give us the round figure. So we'll start by multiplying the signs. Negative multiplied by negatives gives us positive. 6 multiplied by 1 gives us 6. Then plus 2. Then we are going to multiply that. We'll say 7 plus 6 plus 2. 7 plus 6 is 13. We're going to move like this. Then like this. 7 plus 6 plus 2 gives us 13. Plus 2 gives us 15. So we have 15 minus a third. So our answer will be 14 2/3. That's what it is. It's not the best of examples for this one because it doesn't give us a round number. However, this is what you would do to answer this particular question. Basically, that's what it is. This is how you would answer that. My name is Nyakalo Lepoto, as you can see there on your screen. If you would like to enroll with us or you would like to enroll your child, there are the contact details there. My name in full, Nyakalo Lepoto. My contact details 078-383-3396. Email address nyakalo.lepoto@gmail.com. That would be my first name, my surname, @gmail.com. We work with learners from grade 1 up until grade 12, Mondays to Fridays, 6 p.m. to 8 p.m. online. It's like a Zoom call for like 40 minutes at a time. Then for the B.Ed students, it could be foundation, intermediate, or FET, senior and FET, which is what I am doing. We are more than able to help you with that. And with that, basically, let's meet on the next recording. Thank you.